what I'm going to be looking at is nonlinear simultaneous, right? So these are pictures of what those look like, where you will have a quadratic curve and a line crossing path. For example, if you should look at this, you will see that the line crossed the curve one place and the same line crossed the same curve at another place. So you'd realize that there are two sets of answers that you get. See them there? Two sets of answers. Again, if you should look at another case that we have here, the blue line crossed the curve. The blue line crossed the curve here, and it also crosses it there. And you would see that that would have meant that you would have two different answers coming out. So there are times when you have a line and a curve intersecting. Even if you're not seeing the line and the curve, the questions that they would give would be representation of a line and a curve. Or it might be two curves like this. Two curves crossing path. And you could see that's one pair of answer, and there's another answer somewhere here, right there. So we're suggesting that what we're about to do now is learn how do we solve these problems. How do you tell when it is a nonlinear anyway from when it is just a regular? So let us just quickly look at what a nonlinear looks like. For example, you might see y equal to x squared plus x minus 14. And then the other situation might say y is equal to minus x minus 5. If you say the power of any one of the variable raised to the second power, it's no longer a linear. Linear can only be raised to the power of 1. So the fact that something is in there with an x squared, then you know that it's the case that you're going to get 4 answers, as in 2, 2. If you don't see it looking like that, you might see something like so if you don't see it looking like this should say, you will see it looking like this, where the x and the y are multiplying this. You just want to see one case. The moment you see one case like that, you know that you're going to get 2 sets of answers. All right, so that's how you know the difference with your regular simultaneous and when it is a nonlinear. It's only the substitution method can work. So we only can use the substitution method. Now, with the substitution method, you are going to try to isolate the x or the y. But a lot of times you'll get the question with some isolation already, which means that you actually get with. For example, you realize that y is by itself 2 times. You only need it to be by itself 1 time, or the x by itself 1 time. So already we are seeing where y is written in terms of x. So when you're doing the substitution method, it's your responsibility to make sure that you write y in terms of x, or you write x in terms of y, which means that you will try to isolate one of them that you think would work out easier for you. So when you get a question where it's already isolated, you don't really need to try to do it. All right. So most times you will need a third equation to make it so you would create it for yourself. But luckily, when you look at equation 1 and equation 2, you're seeing where you can go ahead and start your substitution. No, I can just say this at this moment, that I can substitute. I can substitute x minus 5, and I can do that for y. And I can do it in equation 1 right now. So in other words, at this moment, I am able to take x minus 5 and plug right in. I am able to bring that there. Yeah, that's what we're saying. Because in order to solve it, we're going to have to ensure that we get rid of one of the variables. So that is why we're trying to do that. So in this case, you're going to see where you have x minus 5 that is taking the place of the y. First move. So now it looks like something because you can't really solve an equation, you know, when you have two variables. You can't solve the equation when you have two variables in this situation. You have to get rid of one first. Always have to get rid of one. So as you could see that we substitute x minus 5 for y here. What we're going to do now is to, when you look at this, you realize it's a quadratic. So I will tell you that every time you do it, it's going to end up with a quadratic every single time. So how you solve a quadratic is to let everything equal to 0. For example, let us say you bring across, I'm just saying, bring across that, right? So on the left side, there's a 0, and this is equal to x squared. Now you will have positive x, and then there's a minus x coming, and there's a minus 14, and then there's a minus 5, there's a plus 5 coming. So you're seeing where that is coming, because you know that how you deal with these, you minus x from both sides, huh? You add 5 to both sides, and you're seeing that's what is going on. So then 0 is equal to x squared, and this is minus 9. All right, so x squared minus 9. At this moment, you need to solve this quadratic. Luckily, you know, sometimes when you make the move, you're going to end up with a simple case like this. Make the move, and we end up with a difference of 2 squared. Look at that. It's a difference of 2 squared. Where now we can solve by saying, all right, all we have to do is to factorize. But because it's a difference of 2 square things, you just open your bracket. And you have the square root at the front because it's x first, and then 3, and 3 for the 9. The square root we use, put a plus and a minus. You'll say either x plus 3 is equal to 0, or x minus 3 is equal to 0. So now, if in either cases, x in the first case here, let me bring up that. In the first case here, x is going to equal to -3, and that's by subtracting 3 from both sides and adding 3 to both sides here. X is 3. So now you're seeing that we have found 2 of our responses for x. We're going to take these 2 x values and find out what is the y value for each. At this time, we could say when x equal -3, and then we want to look at a case also when x equal +3. So when x is equal to -3, let us use the simplest case. For example, remember you can use back any one of the originals to help you. I'm saying use the simpler one. It says y is equal to x minus 5. I would use that, because all I'm going to do is to substitute x right there. So remember, I need to know what y is when x is -3. So -3 with a -5, y is equal to -8, just like that. So what this is saying that is one of our answer would be, therefore, we could say when x is equal to -3, y is equal to -8. So that's one pair of answer. To find the next pair of answer is to do a similar thing. We want to know what is y when x is equal to +3. All we're going to do is to substitute +3 right there. So then y is now equal to 3 minus 5, and that is equal to -2. We can now conclude that when x is +3, y is -2.